Hi guys, welcome back. In the previous session, we discussed the working of the switches that were NO and NC. Let me recap for you guys. So we have NO and we have NC. The symbol for NO is like this. The symbol for NC is like this, right? So under normal condition, the NO could not conduct electricity because the contact is broken. So we will have a circuit that is off. In the case of NC, we will have an on circuit because the current can flow freely. As you transition from the normal to actuated state, right, there must be a signal that turns the NO to FC. FC stands for force close, and now the circuit will be on, and in case of NC, this will be forced open and we will have an off circuit, right? One might ask that how can you transition from normal to actuated state? Now there are a number of methods. Number one is through an electrical signal. It can be an AC or a DC. Number two, a compressed air signal, or also known as pneumatic signal. Number three, it can be a optical fiber signal, an optic signal, right? And number four, it can be a sound signal. And there are a number of other methods as well. However, the most commonly used industrial method for actuation are through a electrical signal or air signal. The last two are not preferred because they are susceptible to industrial processes. For example, sound can be easily interfered by the vibrations of the process or the sound of the process. I'm not saying that the first two signals are not susceptible to noise. For example, electrical noise is present all over the plant. Also, a bent air pipe can stop the whole plant. However, these are easy to trace, easy to install, and have low cost solution. So therefore, we prefer the first two signal. Now, moving back to our original topic, is that how can we make these switches smarter? As of now, we have seen that to actuate them is required a deliberate desired signal. So we need a person to monitor and toggle the state of switches when required. In the case of industrial processes and the mass production, we want this method to be autonomous. So what we do is that we pair these switches up with the process variable. Let me explain. Now, this here in the first picture, we have something that is known as limit switch, right? And what it does, when an object touches or makes contact with the sensing part, it generates an electrical signal which indicates that indeed an object is present and it has made contact. In the second picture, we have what's known as a proximity switch. Proximity switch, right? What it does, it generates a field of detection around its sensing plate. There are numerous technologies that are able to achieve that, and we are going to discuss this later in the presentation. So when an object enters this field of detection, the output signal generates and it is taken to the controller. Now this is a classical float switch. Float switch are one of the many devices used for level control, right? And how they work is pretty simple. The liquid in the column, right? There is a pump and the pipe inside the vessel. Now this part here, it should be lighter than the liquid being used, right? So you install the float switch like this, and if the level is lower than the highest possible level that you require, so the device will float on top of the liquid like this. As the liquid in the vessel rises, it will reach its desired height and will generate a signal when it reaches this point. So we will have a float switch working like this. This is a flow switch, right? In industrial processes, there are a lot of pipes carrying the process fluids across the whole plant, right? So if you install a device like this on a pipe, it can detect a flow. For example, the flow of fluid carries a force, right? And when this force impacts with this sensor this plate here, it tries to bend it, and inside there is a mechanism that will trigger a signal according to your requirement. These are known as flow switches. Here we have temperature switches or temperature sensors, right? Now this here is a temperature controller right here, and this is a thermocouple, a sensing element. However, there are some other methods, easier method indeed, one of which you will find in your home whenever you press the clothes. It is a bimetallic strip. Now, in material sciences, you will know that different metals have different rate of expansion. One of them has a higher rate of expansion, and one of them has a lower rate of expansion, and they are physically fused together at a surface, so they cannot be separated from one another. So they are constrained to expand together. However, due to their different rate of expansion, they will bend a little bit, and hence they can either make a contact or break a contact upon expanding. And this is the common principle used in home iron presses. The last one here, this is a pressure switch, right? Again, it is installed on top of a fluid pipe with the thread here. It is screwed directly into the process fluid, and the process fluid carries some sort of pressure, and this fluid will also enter this assembly right here. Now inside there can be bellows, right, or spring or even strain gauge that can measure the pressure directly and indirectly, and the output circuit will generate at a certain pressure that is written on the top of the instrument. Now all of these have some sort of sensing element to them, right? A sensor is a instrument or a device that senses the change in physical properties of a fluid or a process variable that you are monitoring. However, a transducer, in addition to the sensing element, it has a transduction element, right? What it does, it converts that physical property into an electrical signal that can be understood and processed by the controller for our according to our requirement. So that's it for now. In the next session, we are going to study the limit switch, and we will move our way through all of these switches, and we will understand their working and processes one by one. Thank you. See you in the next one.